we'll do this episode.
All right, well, everyone voted for the Stickman, so...
How much is everyone?
Like 3 people.
Oh, that's good.
That's better than 2.
One.
Yeah, 1. Sorry for the delay in the broadcast, guys. This was... remember we had the choppiness last time? I wanted to try to avoid that, so I was like, oh, I should reset my modem, which was not a great idea. So we'll get started here in just a few seconds. I just wanted to spool out just in case that this gets cut off for some reason, so... That's probably enough. It doesn't cut off from the beginning usually that much. How do I do this? All right. Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Max Moreau. With me is Jeffrey Hawthorne. And the description said that we were going to be doing more balloon fight, but by a quote-unquote unanimous decision, there were a lot of abstentions in this vote. We're doing the Stickman. We might do juggle 2 projects or switch projects at some point. I just didn't. I don't know. I had forgotten about the Stickman, honestly, and somehow I remembered Balloon Fight, and then I went back and I was like, that happened a month ago, so I don't know what happened there. So anyway, we're gonna do Stickman then. So fight go right, and let's get started. What are we doing? Screen. The unanimous decision was 3 votes.
Did you check the microphone?
I did not check the microphone. Are we on the right microphone? We're on the right microphone. Good. Oh yeah, it might be 4. Yeah, because Ravsvek. Actually, I feel bad because he might have been like, "Oh, I'm not watching this episode," and then he left, and then I changed what episode it was. So real quick, I'm just gonna quickly change the link here to point to the one that we want, which is this one. Whoops, that's not how I do it. Copy public link. So if you want to play along, join us at that URL, and you'll be able to play along. That's what we did on the last episode with the Stickman. So let's open it up and see where we're at. Where are we? Oh yeah, it's not in this list because I moved where it is, because I set it up for Perforce. So we're going to do fight go right, open project. And so, on the last episode, we're finally here. We made a level, but we didn't load it. So, here comes the level. We made a Stickman who has a little idle animation, which we did by just moving his torso up and down, which made his hands magically stay in the exact same position like a chicken's head when you move around its body or something. I don't know. Or some other gyroscopically stabilized things. I should do more tongue twisters before the episodes. So, and he also can punch. If we hit control, he fires off a little punch there. It's kind of more like an accusing glare than it is a punch, but...
Looks kind of like he's quickly handing someone something.
Yeah, just, here, go, run. Yes. So... Alright, so, what are we going to add here? Let's play around with this. Let's see about... So let's see how we're going to move him through the scene. Let's give this guy some sort of walk animation. Let's see how IK actually works for the non-artist types like me to actually make something move around. We're probably going to break his legs pretty thoroughly in the process here, but that's all in good fun, right? So, let's make some horrible walk animation. What? What's so funny? You're already laughing at me.
Yeah, well, I'm just assuming we're gonna lock the angles as one of the last things we do, and so I can already picture his legs breaking backwards as he's walking.
Yeah. Yep, we're gonna have some broken legs. So, remember, we have this animation set up, and it's actually set up at The idle just has the body position, but punch, you'll see, just changes the left arm target position. This is actually based on the animation system that is on Stickman here. And so his controller controls all of his limbs and stuff, and so we can put animations on anything that we want. So let's do the right leg target, and let's see if we can move him forward. Let's see how bad we can make this look. I'm going to hit record, and we're going to... see, I already see a problem with this, because we kind of attached, even though he's a 2D character, we kind of attached his left leg here and his right leg there. So this is probably not going to look right, especially if we try to move his leg forward. Yeah. Let's see. What is the extent? If we had his legs... Oh! I didn't mean to move whatever that was. Yeah.
That looks fine.
That looks fine.
It just looks like he's...
Here, I got a good one. I got a
right
good one for us.
slightly.
So we're just gonna do... we're just gonna choose a Y value here. Let's do 1.9 and 1.9. And then we're just going to... I'm just going to put this one at -1, this one at +1, and we will just go over here... Oh, wait, I'm adjusting idle. I shouldn't be adjusting idle. Alright, I'm going to record, and we're just going to remove these properties. And we're going to do a new animation. So we want to click here, choose Create New Clip, and we want this animation, we're going to call it... I'm going to call it a Broken Walk. Because I imagine that's what it actually is going to look like. So, so what we got here? So we got the left leg, and again, we'll just do what we did before. So 1, and we'll not start with the cross position. We'll do the what was it? 1.8, 1.9. Man, now he looks like he has to go to the bathroom. Oh, that was the wrong piece. Hold on, where's his foot target? Give me that target. 1 and 0.9. Alright, so here's our broken walk. We're going to hit record. I'm going to just jiggle these ever so slightly, so bam, and if you do that, it just automatically creates keys. It's just generally the fastest way to create a key for an action, especially if you're just moving something around. And then we will just go like 1 second into the future for right now, and we will move this over to the opposite side, and the other one to the opposite side. And then we'll do it one more time. And we'll make the most stupid looking walk animation ever conceived. So let's just see if we can copy these keys and put them somewhere. Yeah, it worked. So Command C, Command V there. And if we hit play on our animation, yeah.
So it'll help if we restrain the angle of his knee.
Yeah, it might. It might help a little bit.
Then at least it won't be symmetric.
Alright, let's see what happens if we restrain the angles on his knee to fix our horrible animation. Obviously, this is not how legs move in the real world. So, but let's do that just in case. So we've got his legs are controlled by the left upper leg and right upper leg. And so what we want to do is angle limits. So if we just hit 1 here, and we give it the transform. How did we set this up on? Because I swear we did this on the arm already. So let's see how this looks. Thought we did. There it is, left arm. So you just give it. So we just did the bottom. Okay, the one underneath it. That works. So we'll just do left upper leg and then left leg, and the minimum angle. What did we do on the
10
arm?
and 90.
10 and 90. Let's try that. So we're going to do 10 and 90. Remember, at low values in the minimum, we got some, like, weird problems. So let's see what happens if we lock one leg like that. Oops. He's not doing this walk, so. Still looks very much the same.
It is locking over here, though, I think. But
yeah.
It's the reverse of what we want.
Alright, so how do we fix that? So let's try making it, let's just try negating both the terms. No, we can't negate the terms. Alright. So let's try reversing the terms at 90 and 10. And then we hit play on the animation. Yeah, that busted things worse. How do we determine the direction? So I'm just going to play with his leg for a second here. So his leg only bends that direction. Weird. So when we did this on the hand, it happened to work in the direction that we wanted. So now we need to figure out how we make this thing work in the direction that we want if it isn't working in the direction that we want. So what I am going to try... So both of these are kind of clockwise, aren't they? Yeah, they are. Let's see if it always goes clockwise. Let's set the same constraints for each of the arms and legs and see what we get. So we're going to go to left upper arm. That one's done. Right upper leg. 1. We're just going to use the same values on all these except for which transform it is. So 10 and 90. And then we're going to do right upper arm. 10 and 90. So, yeah, it looks like it's always clockwise, which makes people look like cactuars. Yes, very much like cactuar. So, so let's see what we can do to fix that. Since this is a script, we can edit it. So let's see if there's anything in here that looks promising. I may do a cursory evaluation and then run quickly back into the editor.
What if you set the angles to 270 and 350?
Ooh, good call. Complementary. That's a good idea. 270, 350. So which one's
on that one?
Yes, actually on that one because this is one of the broken ones, isn't it? Right upper arm. Yeah.
I didn't think so. I thought we wanted the arms.
Well, this one, look at this direction, right? Like, or do we want the arms both going the same direction? Oh, maybe we do. Yeah, I guess we do.
And don't we want the legs both going the same direction also, but the opposite of where
Yeah.
they're going now?
Ah, I see. You're right. All right, cool. So let's do that. So let's try the complementary on the legs. So we're doing. You already did the math. 270.
350 max.
Yeah, 350. 270. Ooh. And that's how you do it. Yay. Now I've got horse stance. So let's go ahead and fix that. We're going to make his character actually turn to the right by making his other leg do the same thing. So we're doing 270 and 350. So that's 360 minus the two values that we had before. And now he looks like Mega Man. Good. That's a good sign.
Now let's just try that animation again.
All right, so we're just going to try the animation. We're just going to hit play. Wow, it's actually... Wow, it's a lot better. Like, it's still kind of... Wow, it's surprising how much better that looks. I was actually expecting it to be... Like, this is... It's not right, but it's not terrible. So... All right, so let's try and give... What? What's so funny?
It's not right, but it's not terrible. Ship it.
Yeah, pretty much, pretty much. So the extents here are a little bit extreme, especially on the way that they cross. So,
You know what else would make it look good?
what else would make it look good?
If we had something to show that he's actually moving forward. Like a texture scrolling in the background or something.
Yeah, well, we're going to actually be moving him around the screen, so we'll deal with that in a bit here. I guess we could leave it at bad animation and then start doing some movement. I kind of want...
Let's move his leg up into the air.
Yeah.
So that he can step forward. We'll have like an extra breakpoint in between both of the ones we have now.
All right. So, wait. Where do you want...
Keyframe.
Wait, you started doing broken walk? That was weird. Okay. So we're talking about the keyframes here.
So the back leg will move up So
Oh, I see what you're saying,
middle
like
leg
here.
will move to the
Got
center,
it.
and the back leg will move up into the middle at the center. Yeah, like there. But then move that back.
So
leg
move
up.
this up or down. Okay.
Up.
On both cases, or? Oh yeah, back leg. Or front leg or back leg?
Back leg goes up, front leg stays the same because it's
Okay.
not actually moving.
Alright, and then
Wait,
move it back
go
down
to
here.
The front? No, that was the... Or which direction is he moving? That was the wrong leg.
Okay. Yeah, okay. That's because we started with... Okay, so we want... That's what I thought. So we move this one up. We're going to go to 30 seconds and move it like that. Alright, so he does this kind of like strut step. And then we do the same thing over here where we raise this one up.
Yeah.
Let's see how that looks.
The second one is a little smoother.
Alright, so our
I think it's the
problem...
second one.
So I think we've got... That's better than I thought it was going to look. This always do. Alright, so let's actually look at what values we're putting in here just for these things. So we're actually bringing it up further than we can bring it for the legs, and that's why this is so nice, is just because we don't have to worry about that. The constraints and then the IK kind of do all this for us. So I think if we go to this keyframe here at 60 and we bring this a little bit more forward, let's see how that looks. Well, I don't know what I just did there. Wait, why did... Oh. Huh. I am going to undo. There we go.
Something else we could do is at the middle keyframes, move the body up slightly.
Yes, yeah. That's a good point. Actually, let's do that. So, like, somewhere in the middle of the animation?
When the back leg is up and the two legs are together.
Wouldn't it be...
Or near the center?
Yeah. Wouldn't it be, like, around here? Yeah.
Yeah, where the leg comes up.
So the apex would be theoretically there on this one. Okay, whatever.
And
so
move that leg down slightly.
We're going to move the body up.
Although his strut might not be as bad with the body moving up a little bit.
Body up, and then bring body down. So bring the body back down. And then we do the same thing again. Bring the body back up. If we click these, it goes between keyframes. That's what I should be using. I don't know why. So we want to bring it back up. And then that might be too much. I don't care. We'll bring it back down. All right, so
the down should match the starting keyframe so that it doesn't pop.
Oh, yeah. Good point. So let's just go to the body position. I'm going to delete this key. I don't want to delete. Okay, that's probably what I want. Just hit delete, and then we're going to copy the key from here. I'm just going to click on here. You'll get all three for the position. I'm going to hit Command C or Control C if you're on Windows, and we're going to bring it to the last frame. We're going to hit Control V or Command V if you're on Mac. I guess we'll reverse them. Whoops. So
looks like he's sneaking a little bit.
yeah, it does. Now we need to get his arms in the motion a little bit. This is starting to look better than I thought it was going to. So what do the arms do? So let's have him power walk. So as the right leg goes all the way forward, we're going to have the left arm go all the way forward. So just at this keyframe, we want this all the way here. And then we want this one. Oh wait, we didn't set the originals. I liked those originals a lot. So
those ones were there.
yeah. So I want to just jiggle this a little bit and jiggle this one a little bit to get the initial keys. And then we're going to go to the next key set, and we're going to bring this guy forward. This guy back. Kind of give it a little bit of a exaggeration. And then we're going to grab his keys. So again, we want the right arm and left leg targets here. So I'm going to grab, these ones are collapsed, so there's only one key to look at. So left leg and right leg is what I meant, not left arm, right arm. Or wait, no. Yeah. Right arm, left arm is what I wanted. So this one, we're going to copy this key and paste it over here. Put it on the same line. And then this one again, same way. And now we're going to see his whole animation. Notice how we're not really moving the hand targets in a realistic way at all, and yet we have a kind of pseudo-realistic animation despite that. You can get away with a lot of that when you're doing IK. So,
and you have the angle set.
So let's. So he has kind of a little bit of a weirdness once he gets to the goal. It feels like it's a little bit flat. Let's see what the curves look like real quick for this. So if we go to the, so you'll see that if we go to the position here, the green is where is what that's Y. So this one just goes up and down, right? So this is mostly Y, and then the other ones have just a very small amount of motion. And you can see here at the first frame and the last frame, instead of being this smooth hump like we have on all of these, we have this kind of angle here. The way you can fix that is if you click this and right-click and choose flat, it'll flatten it out. And then if you do it on the other side, it'll flatten it out on the other side. And if we do this for all of our major keys, so like here... Matter of fact, can we drag select? Ooh, we can. Does that work? Flat. Oh, nice. All right, drag select. That's what we're doing. Flat. And I'm going to go back to the position and actually flatten out the left and right of this too, even though it's not going to make a huge difference because there's so little of a difference. And then we'll do the same on the legs. If you hold shift while you drag select, you can select more than one thing at a time, just in case people don't know that. And so I'm just selecting both sides and then choosing right-clicking and choosing flat, and doing that again here. Right-click, choose flat. So now if we hit play on the animation, it still looks a little weird, but honestly didn't clean it up as well as I'd hoped it would. But yeah, so we got an animation. So this is his walk. I'm gonna go ahead and stop recording here, just so that we don't break him too much. Now we probably have already broken. This is one of the things that I'm worried about in this process is when we move stuff around, we may break other animations, just because if the animation doesn't have the keys, so we might have to make a habit of putting keys in even if the object doesn't move, though that's probably a bad idea too, because then we can't that might be a problem if we wanted to do animation blending. See how our kind of idle animation doesn't look quite as cool as it used to, because his arm positions don't have a position for the idle animation. Yeah, so let's make sure that everything has a position. We'll see what problems we run into when we do it with that methodology. So his idle, we're going to have him kind of that arm down. Whoops, I didn't record this, so we need to record. And we're just going to give it a position. Honestly, probably every animation should be moving everything anyway, so I don't think this is a bad thing to necessarily put in. And I'm going to put this back to the dope sheet so we can see what we're actually doing here. And let's get his legs somewhat. We should probably have like ground position as something that we have as a set Y value. We'll have to do that at some point just so that all the animations match up nicely when we switch between them. So like if we switch to punch, punch looks good, except for it's only his arm, and his walk. The walk looks like it kind of has the leg position slightly different than the idle. I'm not going to worry about it too much just yet, but something we might have to worry about. But now the idle doesn't look as broken because it no longer uses the static placement of the targets. I'm going to go ahead and see what we got on the comments, just see if there's anything. All right. And Nidge Hunter 314 said it exactly right before we did. And you killed Krabby Game. I have a question that doesn't deal with what's going on here. How does this work? Time.timescale equals time.timescale equals 0 question mark 1 colon 0. Is that like okay, so this so if the time scale, I'm gonna have to look up the operators here, but this basically means this is basically a compressed if statement here. So the if state, what you're doing here doesn't seem to make a whole lot of sense. But I could be wrong. Maybe there's some ninja work going on. But basically, what this means is if time scale. Okay, so if time scale equals 0, then timescale equals 1, else timescale equals 0. So if it equals anything other than 0, oh wait, if it equals exactly 0, it'll be set to 1, and then this doesn't. I don't know why you'd ever use this in anything though. Like that just is a weird statement to make.
It looks like it's just a toggle.
Yeah,
to switch back and forth between 0
it's
and
a
1,
really
like pausing the game and running the game.
Awkward toggle though. Yeah, I guess. Yeah, that's probably what it was for. Yeah, it's if it says if this, whatever's on the left hand side, if this side is equal to 1. Oh wait, if this side is true, then 1. If it's false, then 0. That's what it means. So anyway, back to this. So let's see if we can actually get the character moving around then. We're going to create a C# script, and we're just going to call this like. So we have a separate script for punch, so we might as well have a separate script for this too. We're going to probably have to monolithic this up as we go, but let's just for the moment just have it separately. So I'm going to call this player
Strut.
locomotion.
Locomotion.
Player movement. There you go. Where did locomotion come from? I don't want this. Preferences. Quit. Alright. So player movement. What are we doing? So public, pretty standard ones. We're going to do public float speed equals 1.0f. We're going to have a lot of different things as we go through here. So let's do... Let's just start with that and get the character moving through the scene. So we're going to just do transform.position plus equals, and we're going to do both left and right component. We're just going to, actually let's put those as variables. Public string horizontal, whoops, horizontal axis equals horizontal, and just copy this, paste this, vertical with one L equals vertical. And as a 2D game, we can very safely assume that that up is up and down is down and left is left and right is right. So we can do vector 3.right times input dot get axis horizontal axis and plus vector 3 dot up times input dot get axis vertical axis, or sorry, vertical axis. We want to use our variables so that we can change it if we need to. And then we take this whole thing here and multiply it by time dot delta time. So what this means is
Speed.
Oh, you're right. Times speed times time dot delta time. So what this means is vector 3 right is a unit vector to the right. So that means this will only affect the x-axis. 1 in the right will be 1 unit in the right. So then we use input.getAxis horizontal axis. So that's a -1 to 1. So we'll go to the left if we're pressing left, and we'll go to the right if we're pressing right. This is the same thing. We then add in this vector up times input.getAxis vertical axis. Exactly the same deal, except for this is up and down. And then we multiply the whole term by speed and time dot delta time. So the end of this, we get a vector that points in some direction in a circle from our position and moves us in that direction. So we're going to go ahead and I'm going to play with this real quick and see what we get. So we got a problem here. Unexpected symbol. What did I do wrong? Did something wrong. Must have missed one of these. No, that's right. Speed times time. Wait, what script is this in? Player movement? Yeah. Did I save? I didn't save. There we go. So we save. Yay, problems go away. And when we're moving the character, we want to be moving the whole thing, the whole stickman shebang. So we're going to put player movement on stickman. And if we hit play right now, we can move our character around. And you can see that he is in an incredibly inappropriate idle position movement thing. So let's just make it so that we can move him a little bit faster. Really floaty feeling right now because of the analog stuff. I don't like that. So let's put him at least 6. But then let's make him a little bit less floaty. Let's not have the acceleration stuff because it'll look really weird with our animations once we actually start hooking them up. So let's go to, what was I doing? Physics? No.
Input.
Input, thank you. Horizontal. Alright, so we want to make the gravity 1,000, the sensitivity 1,000, and we want the same for the vertical axis. 1,000 and 1,000. I'm going to go ahead and keep the, whoops, not 100, 1,000, although it probably wouldn't make much a whole bit of difference. So let's move the character around. There we go. Still doesn't look very good because now he looks like he's instantly accelerating and he's still not animating with things. But this is just the first step. We just wanted to get him moving. So let's save scene, save project, and let's actually have him animate. So if we go to his animator, this is his. You can get here by either double clicking on Stickman here, or if you don't have the window, well, that should open the window for you, and then you can dock it. But you can also open the window animator here. So we've already got idle and punch, and now we've got this broken walk. It automatically added itself when we added the clip. So so broken walk. If we are in, we're probably gonna have to reorganize this as we go. Let's just hook up to idle for right now. So I'm gonna make a transition to broken walk, and we're gonna transition back from broken walk to idle for right now. And whoops, that's not what I wanted. Make transition there. All right, and so we've got parameters punch now, which is a boolean. Probably should try a trigger. They've bitten me so many times in the past, and I hate changing them again. Not int. So we're gonna do yeah, we're gonna do a bool. This is how we set up punch, right? Let's see what we did in punch. So we set the punch to false, and then if we have it, we set it to true, and then once it's set to true, this thing takes the rest. So this new bool we're going to call walk. And so when we go into player movement, we can kind of do the same thing that we did in punch here. Just going to copy this verbatim. It's not going to be exactly the same, but so we're going to do walk we're going to do walk, but then the reason for this is going to be different. So what we want to do is actually, let's do this. Let's go ahead and make a vector 3 move direction equals, actually I'm going to call it movement vector. So we're going to set it to equal to this term right here. We're going to go ahead and delete this and replace this with our new little movement vector. And then we want to basically, if the movement vector, whoops, I need a semicolon there. So if movement vector does not equal vector 3.0, that's probably a bit insane, because that means if we have any motion whatsoever, it's there. But considering we're instantly accelerating and decelerating, it might not be a problem. So let's see what this does. So if we hit play, we get a problem because we don't have an animator, and that's because animator is not a built-in. We have to actually reference it ourselves, so we just have to do something similar here. So I'm just going to grab that and paste it here. So there you go. Animator, get component animator. Now we have one. So if we hit play and move our character, well, it did say walk, so that's good. Oh, and actually this is not working right at all. It's just changing between doing an idle and doing a little walk step. And that's because we didn't actually change our transitions here. So our transitions should be, we want this to be conditions walk, wait no, conditions walk false, and conditions walk true. Let's see if this works now. So we are just idled there. We stay idled. Good. I start walking, and he starts strutting. Good. Very good. This is good stuff. It's almost the right speed. Now, he moonwalks when we go backwards, but we can fix that too. So, let's see. Can he still punch? He can still punch. Now, if he's walking, he can't punch right now. So we may have to figure out how to deal with that later.
Can't we just do a transition state between punch and walk?
Possibly. Though we probably actually want to do some sort of blend into that punch, so that we can continue walking while we punch. I don't know if that would make sense, though. Maybe that wouldn't make sense. All right, so let's try to fix the moonwalk problem. Or do you like the moonwalk problem? So there's two ways we can fix this, right? Let's do both of them, one at a time. So one way we can fix this is making it so if we're moving forward, so we can use some vector math to make this simple. We're going to use a vector dot product here. So if we do vector 3 dot, that's confusing to say, but it's very clear when you see it in text, dot, we're going to do vector 3 dot right and movement vector. So if we dot these, so if vector 3 dot vector 3 right movement vector is greater than 0, then we're going to set animator dot wonder if this is going to be as easy as I think it's going to be, because it might not be very easy. What I wanted to do was reverse the animation. Hold on. Ah, my face. Reverse animation unity. Animator. So we're animators, right? Yeah. Animator speed. Alright, so if we do animator.speed, oh, there we go. Speed equals 1.0f. Or actually, let's multiply that by, wait, no, that's not right. Yeah. Animator.speed equals 1.0f. We'll just hard code it for that right now to that because we don't want it to actually change. Now, this speed that it's referring to is actually, if we go into one of these, this is the speed that it's talking about. It's not talking about anything else. So this is not affecting our character speed. It's just affecting our animation speed. So we're going to hit this, and we don't need this other if. We actually just need an else here. So I'm going to do greater than or equal to 0 because I prefer facing right slightly more. Very, very slightly. So I'm going to hit play. And so now when we walk, we advance, and then we walk backwards, it breaks really badly. Interesting. Does it not loop backwards anymore? So like if I keep walking forwards, it seems to walk just fine. But if I walk backwards, it only goes... Wait. Weird. Really?
Oh. Well.
Alright. Yeah, I don't like what that did. That's just weird. I would have expected that to just reverse and loop like you would expect it to loop, but it doesn't seem to loop. Alright, so let's look at the animation files to see if they're set to loop. I think they are. Yep, loop time. What does loop pose mean? I don't actually know what that means. Yeah, so I guess it only loops forward right now. I swear there was a time when that worked differently, but oh well. I'm going to just comment this out for right now, and we're going to call this attempt to reverse animation, maintain facing. We don't really want to maintain our facing anyway because we want enemies to be able to come from behind and then actually punch them to the left as opposed to having to back up and then go around them. We could make the game like Karateka or something where, well, actually that one you can turn around too. Yeah, this doesn't make a whole lot of sense. I just wanted to see what it looked like when he was backing up, which we can see now, but we have to like spool him up a few times first to the right before it works. So we can do like a few walks. It's like, oh yeah, and then it's like, oh, I don't like this at all. And it still actually doesn't look like it's even reversed, so... Oh wait, that's because we saved this. Alright, yeah, never mind. So let's do a different type of reverse. So what we're going to do is, if... we're going to grab this same little term here, because we actually do care about the facing. And we will just do the if-else again. And what we're just going to do is set our rotation. So if we're going to the right, then we will just set, since this is on the very root of the stick man, we can set the Y rotation. So transform.rotation.Y, and we can't directly set that. So we have to do, there's reasons we can't directly set that. It'll give us an error. Actually, let's just do it. Transform so that you know what the error is. Euler angles rather. Local Euler angles. No. We don't want the global. Just normal. Euler angles dot y equals 0.0f, and we're just going to do the next thing here equals 180. So if we save, we'll get a compile error. And it says we cannot modify value return type of modify the value type return value of Euler angles. So you have to store it in a temporary variable. So what that means is we need to do vector 3 new rotation equals transform dot Euler angles, and then we take this. Actually, let's just change it to new rotation here. We change the y, and then we set transform dot Euler angles equal to new rotation. And we can do the same thing down here, except we just need to change this to 180. So if we hit save, this should solve our compile problems. No, it did not. Oh, vector 3. Wait. Oh, yeah. We just need the y. We don't need Euler angles there. All right. So we go right. We go left. It doesn't look very good. And the reason it doesn't look very good is because it actually is reversing all of the things in our character. If we look in the scene here, if we go to game and scene at the same time, and we move him around, you'll see that the moment we go in reverse, these two things are actually flipping, and so are his legs. It's just you can't tell because the IK is still locked in the same way that we had it locked before. So this is an interesting little predicament. So we can reverse these things, but basically if you watch me do this, we rotate along the Y, or we don't because we've got a script running, so let's get rid of the player movement here for a moment, and let's rotate this character along the Y. That's not rotation. And why are these blocked out? So as he rotates, I'm actually curious, does he do any 3D-ness here? He's kind of doing some weird stuff. This IK solver might actually work in 3D a little bit. I'm not sure, though. No, probably it looks like it does not, because those things are totally, outside. So, yeah, this is purely a 2D IK solver, like we thought. So, let's go back to 2D mode. But, yeah, so rotating it has his arms go into the new positions, but they're still facing, they've got the wrong, facing, or there's a fancier term for what that is, chirality or something. So chirality, that's what it is. So we need to reverse that. So the manual way we could do is we could just basically grab all of the simple CCDs and then just replace whatever's in here with like some sort of math that changes it between the left-hand side and right-hand side, where basically it's 1090 or 270, 350. The other way we could do it is we could change the script to see how it actually solves this stuff. I'm just going to do a quick browse to see if there's anything that looks easy to do that. So where are the extents? So if we go to angle limits, I just want to see where this goes into the... So on validate, here it is. Oh, it has to be between 0 and 360. So on validate, this is an interesting one. We haven't actually talked about this on the show, and it's actually really useful, and I didn't know about it until very recently. What this is called in the editor when you try to change a value in the editor. And so if we change this to, like before when we did negative 50, it switches back to 0. That's what that is doing. It basically says the min and max have to be clamped between these ranges. So let's go down further. Angle limits. So that's a cache. We don't care about that, although we do care about it now. So now we need So now we need to actually look at node cache, where this is happening. So here is where the angle is being limited. So node.min, node.max. Angle minus equals parent rotation, clamp plus equals parent rotation. Is used anywhere else? Yeah, I didn't think so. So this is where the magic happens. So let's make it so we can reverse this thing. Let's just make it so that we have that capability. And I do want to do it in this code just because it seems like it would be more useful than having to go through and specifically change things elsewhere. We could totally do it, and it really effectively is doing the same thing because we're going to just do it here. But I think it would be better to have it as a feature. So we're going to do a public bool reverse angle. Reverse angle limits equals false. Start at false. And then what we are going to do is... So let's just see no.min, no.max where this is used. Oh, wait, yeah, this is because... That's right. Yeah, this is exactly right. So, if not node, what do we call this? Reverse angle limits. Reverse angle limits. Then we do exactly what it was doing right here. But else, if it's the other case, then what we want to do is angle equals clamp angle. And what we want to do is reverse the terms. So we want node.max, and then we also want to so node.max has to be between, both of these values have to be between 0 and 360. If they're closer to the left-hand side, we want them to move to the right-hand side. So so a small value should become a big value, and a big value should become a small value. Just thinking this through. This is probably simpler than I'm making it out to be. So node.max. So if we just did 360 minus node.max, that should do it. So if node.max is 0, it'll be 360. If it's 180, it'll be 180. And if it's 270, yeah, that's exactly what we want. So 360 minus node.max, and then 360.0f. We want the f here, actually. Minus node.min. And that's it. That's all we have to do. So, so now if we... No overload method for clamp angle takes 2 arguments. Oh, yeah, we need angle here. Should look exactly like this one, except for with different clamping values. So now that we've done that, this ought to work. So if we go into player movement, we need to actually change this. So, so we have more than one of these CCDs that we have to reverse the angle limits on. So we still have to collect all of those. So I'm going to actually apply this to our prefab and save before we break everything at some point. So
you could make it a static.
Static? Oh, yeah, I could make it a static. That would be bad, though, because if we did the same animation style for the enemies, then they would all be locked, too. So I think it's probably safer to actually collect them. So what we're going to do is we're going to do that at the beginning, though. So we're going to do a private simple CCD array. Yeah. And the simple CCD array is going to be called IK solvers is what I'm going to call them, because simple CCD means very little to me. I kind of wish it was just called IK solver. So IK solvers, and what we'll do is in this case, okay, so we need to actually collect them first, right? So just like we got the animator, we're going to do IK solvers equals get component, except for we're going to do get components in children.
Does that go through every level?
Every level. It does, yes. It's nice. So, and we want simple CCD as the type. And so that's our IK solver. So this will actually return, if you look at it now, it will return a simple CCD array. So it's exactly what we've got here. So we've got our IK solvers. And then we just, at the end here, we're just going to do for each IK solver. Wait, no, sorry. Simple CCD. solver in IK solvers. And all we have to do is solver dot reverse angle limits equals true in this case, because this is when we're moving left, and then equals false in this case, because this is when we're moving right. So if we hit save and hit play, then in theory, when we move to the right, we move to the right, and when we move to the left, we move to the left. There we go. Strutting our stuff, moving right, moving left. Now, the problem is, when you stop moving, he immediately reverses. So that's not cool. So let's actually just get rid of this equals 0 and see how it works. I just am curious if that'll just solve it. It'll just work itself out on its own. So move right. Nope. Now it's the opposite. Oh yeah, that's right. Because what we need is else if.
Greater than 0.
Yeah, we just need to do the same thing here. Although let's not redot it. Dots are cheaper than some operations, but they still have a cost to them, so I'm going to actually save this into a temporary vector. So this dot product just returns a float, so float dot product equals that. And so if dot product is greater than 0, and else if I accidentally hit build. You can build from here. If you hit Command B or Control B, you'll build in here, and you'll get errors in the console. I just don't use it because sometimes it does things that I don't like it. So if you have better results with it, go ahead and use it. So dot product is less than 0. And no semicolon there, that would be bad. Save and hit play. So now he's looking right, we move right, move left, he moves left. When we stop moving, he stops moving. Everything's smooth.
Add some vertical movement.
Add some vertical movement. Well, we've got vertical movement, see? We're moving vertically.
Into your testing.
Okay. So one of the things with the vertical movement is we're going to probably want the vertical movement to be slower than the horizontal movement. Right now we have them both at one speed value. Because it feels really weird that you can just, like... I don't know, maybe it doesn't feel really weird. I just can't believe his walk looks this good. I thought it was going to be really, really crusty by this point in the episode. Although it is at the end of the episode, but I still thought it was going to be crusty. So this is actually awesome. I love that we got this. Let's just for right now, because I think we're going to have to do it.
That you're facing the other direction.
All right. Oh, good call. Punch. It works. We still have to be not moving. Here, let's just see what happens if we hook up punch to broken walk in the same way that we have them hooked up right now. So if we just do this and then make transition this, and so what this will be is if punch now is true, and then the transition back is a little trickier. So exit time 90. So we actually want exit time 90, but we need to actually put another blocker on these things. So if we hit add here, we can add another requirement. So on this one, walk has to be true, and on this one, walk has to be false. So if we hit play now, so if we punch, he goes back into idle. If we walk and punch, he walks and he goes right into the walk animation again. Now you can see that his legs like all mess up and stuff, so we're gonna have to figure out some nice way of handling that. There's two ways. The traditional old school way of doing things would be to have a separate punch while walking animation, or make the animation fast enough that no one would notice. The new methodology that we can use is we can use animation blending. So we could actually make it so that his arms do one thing and his legs do another. But we're going to have to save that for another time because that is a lot of setup. So I'm going to go ahead and call this a wrap. We're going to save the scene, save project, and we're going to go ahead and check this into Perforce. P4V. And... so we're just going to go to FICO right, reconcile offline work, reconcile, and we are going to submit the change list. So these are all the files that we changed. It looks about right. Walk animation strut. And basic movement. Looking good. Actually, I'm going to quit. It's too late.
Bidirectional.
Bidirectional. Submit. All right. Well, I'd say that was a good episode. But where's my buttons? Here's my buttons. Thanks for joining us tonight. I hope you enjoyed the episode. I know I did, and I've been saying that a lot lately, but I'm going to just stick with it. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. You can tell Phil to get well at Magmalemur. He's actually feeling a lot better. His arm still sucks, but he's back at work and stuff. But they're working him pretty hard right now. So he said he should be here on Monday, which is going to be awesome. And yeah. So thanks for joining us, and you guys have a great night.
Good night. Looking forward to our fill rate increasing.
Me too. All right, so banter time. I'm going to go ahead and switch the screen because last time I didn't switch the screen, I kind of felt regretful about it, but not regretful enough to fix the problem.
Let's look at the comments.
Main screen. Actually, let's just do main cam. Let's do both. Yeah, and look at the comments. All right. So when walking left, you probably just want to set the local scale at X to -1. Yeah, that would actually also work, but it would still have the same problem with the, we would have still run into the same IK problem because of the positioning, the way that those work. Damn, that stick figure is beautiful. Yes! Ternary operator, get well Phil, good show. All right, well, that was successful, I'd say. While I'm here, before I forget, I'm going to actually name this what this ended up being. What did we actually call this? That's in somewhere else. Open link in new tab. Video manager. Videos. That was just called IK. Alright, well, I'm going to call it Fight Go Right now for real. Fight Go Right Part 2. Previously, inverse kinematics.
Oh.
Yeah, does that compile? Yeah, that compiles. And we make our stick figure have an awesome animation, and we call it Broken Walk. I would say that that's right. Walking animation. That's not how you save. Save. Alright, and that's probably enough banter time, so. It wasn't really banter, it was watch me do my required stuff on here. What are we doing? Video manager. Live events. Live control room. End it now.